So every time we want to find the equation of a straight line graph, we need to use the equation y equals mx plus c. Well, it's the way I like to do it. If we want to find the gradient here, which is m, we're going to have to do y minus y1 over x minus x1. So we need to pick the 2 points here, L and M. So let's start with the y's here, minus 4, minus 2, and then to the x's, over 7, minus 1. So minus 4 minus 2 is minus 6. 7 minus 1 is 8. So minus 6 over 8, which simplifies to minus 3 over 4. Put your minus 3 over 4 gradient into your y equals mx plus c. And then substitute in any of those, either L or M, the x and y coordinates, to find your plus c. So that's what I'm going to do here. I'm going to use L, 2 is y, and minus 3 over 4 times minus 1, add c. Well, minus times a minus is a positive, so we've got 3 over 4, add c. Let's rearrange that. We have 5 over 4 equals c. So let's rewrite our equation. Y equals minus 3 over 4x plus 5 over 4. So this minus 3 over 4x is going to the other side. It's going to be 3 over 4x, add y, add 5 over 4 equals 0. Okay, and it actually says here that a, b, c are integers. At the moment, they are fractions. So if we multiply everything by 4 in this equation on both sides, we end up with 3x add 4y add 5 equals 0. Fantastic, so they're all integers, and it's in the form of ax add by add c. So you get your method mark for taking away your y from your y and dividing by your x and your x. Take away your x, and you get your accuracy mark for writing y is minus 3 over 4. You get the second mark for your y equals minus 3 over 4x plus c, or whatever you found here for your gradient. And the final mark comes for getting the equation correct, and that's the final accuracy mark. So in the second part of this question, I'm going to use LM as gradient, and I'm going to find the perpendicular gradient, MN, this one here, so I can find this point here, P. So in the first part of the question, we worked out that LM's gradient is minus 3 over 4. We know the gradient of LM times the gradient of MN equals minus 1. So that's minus 3 over 4 times what equals minus 1. Well, to make it 1, we go 4 over 3. Brilliant. So now we have the gradient of the line, and we have a point on the line. We can use our equation y minus y1 equals our gradient, which is m, times x minus x1. Okay, so we can input the points 7 and minus 4 into here. Brackets 4 over 3 times x minus 7. This has essentially given us the equation of our line. So if we want to find where our x value is 16, what our y value is, we can put 16 in as our x value. So this is going to change to y, add 4 equals 4 over 3, 16 minus 7. Okay, so 16 minus 7 is 9. Y add 4 equals 4 over 3 times 9. Let's rearrange this equation, so it's now y equals. So y equals 4 over 3 times 9, so 9 divided by 3 is 3. 4 times 3 is 12. And then we're going to minus 4. So y equals 8. So where are the marks given on this question? Well, you get 1 mark for noticing that the gradient of the original line and the perpendicular line multiplied together to get minus 1. So there is our first method mark. Our second method mark is for getting a value in the form of y equals. And our third mark is an accuracy mark for getting the term y equals 8. Okay, and this last part of the question is just logic. If you haven't already drawn this diagram, I think you probably should draw out the diagram. And we're just trying to find out what the point is there. We want to know what the y-coordinate is of k. If you just think about it logically, this point k needs to be the same distance away from n in the x and the y that L is from M. So if we can work out what we need to add to M to get to L, we can just add that from N to get to K. So if we want to go from the coordinate 7, minus 4, or we want to go to the coordinate minus 1, 2, this is M and this is L. Well, in the x coordinate, we've gone to 7 to minus 1, so we've had to minus 8. And in the y coordinate, we're going to have to have gone from minus 4 to 2, so we have to add 6. So as we said before, all we do is add this vector, minus 8, 6, to our coordinate at n, which is 16, 8. Minus 8 add 16 is 8. 6 add 8 is 14. So our new vector is 8, 14, or the coordinate 8, 14. That must mean our y value is 14. Well, how the marks are given for this question: if you worked out 6, add the p value, you get 1 mark, p being what you got for your last question. And if you've got the answer, y equals 14, you get the accuracy mark. Good job.